Okay, this is a video to illustrate using three-dimensional coordinate systems to represent a three-dimensional force vector. So this book, or this particular problem, was ripped straight from the pages of the statics book. It says to find the components of a 100-pound force shown in the diagram below. So in the diagram below here, they have a three-dimensional coordinate system, and they show the force as the arrow here. And to know the way it's directed, you have to look at the tail and the line of action of the force, which goes from A to B. So that's going to determine our direction. And we want the magnitude of the vector to be 100 pounds. Now the distance from this point A to the point B, the distance it would be found by the distance formula and would not be 100 pounds. So you have to make a distinction between the force vector, which has a magnitude of 100 pounds, and the actual diagonal of this rectangle, which is not 100. So um, it's probably the best idea for working with problems like this and for writing vectors in general is if you write a unit vector in the direction you want, then you just multiply the unit vector by the magnitude. So in this case, we'll write a unit vector that goes from A directed toward B, and then once we have the unit vector, we can multiply it by 100 and we'll have the force that we're asked for. So we start off by looking at what the coordinates of point A are. And on the x-axis, how far do you have to go from the origin in the x direction? And you see that over here on the right side of the diagram, that's going to be 6. So the x-coordinate of this point A is 6. Now the y-coordinate is how far you have to go along the y direction, and you see that down here at the bottom of the diagram. So that's going to be 7. Except, I'm sorry, the point A, that's not 7. The point A is actually on the x-axis, so that means that y is actually 0. Now, the z-coordinate, again, you have to look in the z direction. And since this point A is on the xy plane, in particular, it's on the x-axis, this tells you that the z is also 0. So the coordinates of point A are 6, 0, 0. Now, to get the coordinates of point B, we want to do the same thing. So point B is on the YZ plane, and so the x-coordinate at point B would be 0. The y-coordinate of point B, and this is what I was almost making a mistake on before, the y-coordinate of point B, you have to ask how far along the y-axis do you go, and that would be 7, and you can see that down at the base of the sketch. So this would be 0, 7, and then the z is going to be how far above the xy plane the point B is. And somewhere on here they have, oops, over here on the left corner of the diagram, you see the 2 feet here. That's how high you are above the xy plane, and so the coordinates would be 2. So once you have the coordinates from A to B, the coordinates of A and B, we can write a vector, and I'll call it R, and I'll call it R with a subscript of AB. Now to get that vector, we just have to take the difference in the coordinates. So the x-coordinate, we'd have 0 minus 6i. And then the y-coordinate, we would have 7 minus 0, j. And the z-coordinate, z minus, or 2 minus 0, k. So the vector then is going to be negative 6i plus 7j plus 2k. Now that's the vector from A to B. That would be the vector that spans the diagonal of the box here. But we don't want that vector. We want a unit vector in that direction. So I'll say U for unit, and I'll put AB again. And to get the unit vector in that direction, we just find the magnitude and divide it into the vector RAB. So it'll be RAB, the vector we just wrote, divided by the magnitude of the RAB vector. So that will be negative 6I plus 7J plus 2K divided by the magnitude, and the magnitude will be the square root of negative 6 squared plus 7 squared plus 2 squared, and that gives us this gives us point to 2 decimal places. It gives us 0.64 I plus, and that's negative 0.64 I plus 0.74 J plus 0.21 K. Now that's our vector, unit vector, along the direction from A to B. Next, to get the final answer, what is the force vector? We just have to realize that the force vector is going to be the magnitude of the force times the unit vector in the direction of the force. And so that would be 100 times the vector that I just recorded there, negative 0.64 I plus 0.74 J plus 0.21 K. And so to 2 decimal places, the force vector then would be negative 64 I plus 74 J plus 21 K. And that's your force vector. Okay, hope this helps.